In this video, I give you a full walkthrough of graph engineering. You learn how to turn raw network data into graph features to create actionable context for production AI agents. To reflect real-world complexity, I chose Dutch road network from a major city with thousands of road segments, including maintenance data. For the tools, OpenStreetMap, NetworkX, LangGraph, and more. I also show you graph-powered AI agents with graph orchestration, combining agent reasoning with graph intelligence. I'm Maryam. I've built many large-scale graph systems and 400 plus production AI agents. The first thing, we use OSMnx Python package to easily download geospatial features from OpenStreetMap because we need a part of our data, and you can always go to full documentation. Here's everything, how to use it and how to install it, but it's quite straightforward. Load and download the graph. In this case, we use Utrecht. Utrecht is one of the major cities in the Netherlands, close to Amsterdam, in connection with it, and also with Den Haag and Rotterdam. And this is actually live webcam of the Ministry of Transport. It's a quite busy city, one of the most important cities in the Netherlands. And in configuration, you basically can give a radius, how big is Utrecht, and how much of radius you want, and after loading it, we save it as an object to save time. And now we have our raw data, and we want to change it to a network data. For that, we can use NetworkX. Just before showing you how we use NetworkX, so a raw graph, a raw network we loaded from OSMnx, the raw data, if we load it, it's not gonna be useful to us because we have intersections as nodes, and edges are the road between each of the nodes, and some geometry, length, name of the road, topology, but it does not give us the condition or traffic or how critical it is, the closure impact, and maintenance priority. So we can now go ahead and use that raw data, like that graph model, and just give it to AI agents and make some decisions. Of course, normally typical agents just get text, tables, tools, and that's good for the facts, but not all of the problems are like this isolated thing, because in the road, the condition of that road isolated is not enough for showing the importance, because it's always connected to the network. So we want to know what's the impact of maintaining that road. So road importance is more of a relationship view than a property view. So what we want to give our agent as context is an engineering graph, which is adding that relationship and connectivity. And that's what we are going to engineer. Basically give a graph model, then we extract features from it. We apply some algorithm, graph algorithm, and then have some graph tools inside a agent system, and then we can decide. That's actually, in a nutshell, what we are going to do. After using an OSMnx, we're going to use NetworkX. NetworkX, if you have worked with graph, is that library that built the graph. I will explain all of the graph concepts in a minute, but this is NetworkX, the one that you want to use. So loading that data and building that is such a smart and a small code. How? OSMnx basically change your street data to a graph data directly. So it gives you a NetworkX graph. So you already have a raw graph data, and that's really amazing. So you basically read that graph from the point, you make a graph, and that graph you can save. So it's save a GraphML in a path. And after that, we can get anything we want. So here we can see that from a multi-graph, get nodes and edges in a data frame. So this library is really handy. And after that, because we need maintenance data, I have worked with that maintenance data, but it's confidential, we need to create it synthetically. So to our edges, to our roads, we add that synthetic maintenance data based on condition, age, traffic. I create segments. We give road ID, road name, conditions, service age, traffic, maintenance cost, and maintenance status. So we've got our graph model and we built some graph features. We need now some graph algorithms. In the code, we have this priority weight, how critical an edge is, the edge betweenness. So I can imagine that needs a little bit of explanation. So let me show you. These are all of the concepts, core concepts using GraphRoad. By the way, if you want to know how to build AI agents, I have a free 30 minutes training, a deep dive, plus 2 practical guides. It's the first link in the description. So graph is a set of things and the connections between them. Example, Utrecht, Amsterdam, London, any city you want. Let's say we've got 2,000 points and then about 5,000 connections. A node is also called a vertex. It is one intersection. You have the roads, you always have intersections and the roads that connect those intersections. The edges are, in this case, one road segment, just a connection between 2 nodes. Then we have directed edge, one-way or two-way streets. Then we have weight, so a number attached to that edge. It could be road length, the cost of that road, so anything could be a weight. Then we have degree. So imagine how many edges touches a node. So if you have a node that's just connected to one road, it's okay, but you have 4 roads connected to that one intersection. Naturally, that's quite an important place. Then we have shortest path. It's probably quite intuitive. The route with the lowest total weight. Then we have centrality or degree of centrality, asking how important is one thing. It could be like the degree. So it should be like, okay, this one has 4 intersections, this one, so this is more important. So the centrality of this one is higher. But it could be also between the centrality, which we use very often. So important is how many other people, shortest paths, run through this one. So because it's big connected network like that, you cannot just think of it only as the degree, but more like between the clusters of connections. And then we have it 0 irrelevant and 1 is everything routes through that. Then we have connected or disconnected. So if we have connected, everything is closed, is a closed loop. And a disconnected is that you have just some pieces that there are no connection between. For the roads is where, for example, there is a road where no cars are allowed. So there is a disconnection. Then a graph copy. It's important to have like the full duplicate of your graph. You can safely edit it. A lot of these algorithms are by default in NetworkX library, so you can use all of them. So after explaining the concepts, understanding these metrics should be easy. We compute criticality, which is the degree of betweenness centrality. And that's directly from NetworkX. And we do compute priority, which is the combination between condition score, criticality, and traffic volume combined here. We have the walk in a chain. Then we simulate a closure. So if we have a closed road ID, I also explained that, a closed loop. And the reason that we need that is for shortest path and the path weight. Because later on, we want to use all of that for our maintenance AI agents. What we return is the original node, destination node, baseline distance, alternative route node, the detour, because we want to find the shortest path, the detour, distance, extra, if the network is disconnected, because then we know there is no path. So we have again that property versus relationship. We have condition age, repair surface, and then we've got here the shortest path, detour, bottleneck, and connected area. So a relational feature is when we have a road, and in that road we can say the road A, it has a condition, and and road B has a condition, and the maintenance priority is based on those 3 criteria that I mentioned. So then that road role in the network become a feature. Now that we got all of these network algorithms, we want to change them to some tools. So get some road detail, we rank maintenance candidate, and we simulate road closure. And the reason for that is we want to do this part. So graph tools can be used for our AI agent to give us advice. So we go to our graph tools. This is get all of the roads. You get always everything from our multi-graph. Just listed. Worst roads, we just sorted based on the condition score. Get road details. Every details of our road. Then we rank maintenance candidates, where we get our graph, we look at our budget and limitation, and then we can basically use those maintenance costs. These tools are deterministic. You want to translate your business, the road engineering maintenance, here to deterministic rules and not just give it to LLM and ask for some advice. That's actually this part. And we simulate also road closure, because closure has always consequences. Because we want to make the user interface friendly, we're going to build a map. There is another library I want you to remember, and that's Folium. I've used this in my Agents Mastery OpenAI for GeoAgents. It's really lightweight and it's really great to build GeoAgents with it. We have building a Folium map, starting with getting those Utrecht Center information. First, we want to know which part of the city we have, and then we add all of the coordinations and colors on top of that. And the colors we can use for example, closed, alternative or selected. And I will show you in a bit in our Gradio dashboard. And we use all of those metrics, tools, and graphs that we have created in synthetic data, and we bring everything together. Now that we have our map builder, we can go ahead and do our AI agents. We can go ahead and build our AI agents. Our tools are deterministic, so no fabrication of the rules. You have some formatting here. We're going to do 3 agents: road health, maintenance, and the closure system. So a graph power agent will have in the road health, which roads are in the worst condition. In the maintenance, we give budget. We have this, what should we repair first? And the closure impact is that what happens if we close actually road N237, for example. So agent reason over deterministic graph results, and does not just come up with some rules itself. So the maintenance agent, for example, gets the worst agent from the tools and the rank maintenance candidate, find the data, and then come up with explanation, maintenance system, and return all of that. Again, because it's deterministic, our agent kind of just make it fluent for us, but it's not just come up with systems. For closure, the same. Here we say, it's basically routing. We say, okay, now you're a closure agent, so you need to go to road details and then simulate road closure. Also fall back when there is no LLM. And of course, because you are using LLM, this is where we also use our OpenAI or Anthropic keys. And now we have our graph. And we want to also build an orchestration graph. When we were building our domain graph, our road engineering graph, it was intersection road segments relationships. For agent execution graph using LangGraph, and that's just a kind of query type. And then we have health plan and closure agents, so kind of routing. So we have the graph of our data or context, and then also the graph of our agents. And that's in workflow, and we are using LangGraph. And LangGraph is amazing for building a graph with states. We add nodes, road health, maintenance, and closure. The type of node should be like which one we want to go. And so we add first a conditional edge, and then road health, maintenance, and closure. And before building it, we basically need all of those informations, loading the graph, synthetic information, compute, criticality, priority, and we build a workflow and get worst roads, for example. And once we got everything, we bring them all together in a Gradio dashboard. Gradio is one of the most lightweight libraries to build a user interface. As always, using a Gradio, we add block, rows, markdowns, some columns, drop downs, and input and output. Let me show you the end result. This is our Gradio for our Utrecht, that part of network that we have already loaded from OpenStreetMap. And we have created conditions for them: good, watch, poor, or critical. That's the colors. If I go to maintenance graph, I give a budget of about 50 million for 2027. We want to see which road should be maintained first. Ask road agent. This calculating, it says this one, the condition, criticality is very close to 1, traffic, surface age, maintenance priority, estimated maintenance costs. Of course, this is completely generated. And if I go and use a road health, I will ask which road is the worst in the worst condition. I will ask the question, get this Federica's strat, and the traffic, how much it is per day, the condition, critical maintenance priority, not very high, estimation maintenance cost. So this is our being in the worst condition, but it's not that critical, completely different priority. And I have, you can see all of these streets, just choosing any street that I want. And the last one is closure. If I say what happens if you close this road, it's processing. So it gives quite high criticality, red, maintenance priority, and the price, and also the surface age. So this is quite advanced, and you can just build this for the whole network. That has been also one of the things that I've done during my PhD for the whole network of the whole country. With AI agents, you just have that extra level combining two very powerful things together and creates these amazing systems. That's why graph engineering could be one of the things that you want to have it in your pocket when building production AI agents. So what we have built, we had a real road network. We had NetworkX domain graph, nodes and edges. We created some graph features, conditions, criticality, and priority, etc. Then we used and built some deterministic graph tools, rank, details, closure. Then we built some specialist AI agents like health planning and impact. And then we've got Folium and Gradio to just make actually that usability, the map plus explanation. So you can now add graph for more context, and you can create these really high value AI agents, production AI agents. Another thing that can be amazing and add a lot of value to your production AI agents is using forward deployed engineering. I have a video for that also with an end-to-end project that can teach you how to get production AI agents to another level. I see you in that video.